Hi there. So I'm going to try to give a little demo of installing packages and using the software UV to create virtual environments for Python. So the background is that each time you make a new project inside of Python, new app, a new data science project, typically you'll need to install lots of packages to get the app to work. And each of them each package you install will itself rely on some packages and so on and so on. So there's actually each project is supported by a large hierarchy of dependencies. And as time goes on, the versions of these dependencies change and there's incompatibilities develop. So basically you kind of need to have each project have its own version of Python with its own dependency tree to safely operate Python. And so this is where the idea of a virtual environment comes from. So we'll make one here. So I've just got my terminal open. I'll go to the desktop, make a new directory called Python project. Go into it, and we can open VS Code inside of this folder here, for example. Inside here, we could make a new file, a Python file. Call it test.py. Now, if I have only some very basic stuff in here, so like print hello world, then this probably will run right now. So if I hit the play button up here, it will run that code. It will print out the results, and that's because Python is somewhere already installed on my machine. So if you think back to in the previous recording, I explained the terminal, explained this idea of the path variable. So basically Python is on my path somewhere. And in this case, it's found one in my home.local bin directory. So the issue here is that, as I said, each version of Python has its own configuration, its own setup, and its own reason to be there. So on every Mac computer, Python comes pre-installed. I don't know what it's doing, but we can't really use or touch that Python. We can't modify that Python installation because whatever operating system functionality needed it would be broken potentially if we start playing with it. And for example, and I gave a simple example here of printing hello world, but for the course that I teach, we'll be using, say, data science libraries like PyTorch. So if I try to import that and run again, we'll see that this code no longer runs because that globally installed Python doesn't have all the data science packages that I need to actually do my own project. So that's why we need to make our own virtual environment. So at the moment, this folder that we have, it's just empty. It just contains this one test.py file. So what we'll do is we'll install Python into this folder using UV. So UV-venv is the command, and you can specify which version of Python you want. So Python 3.14 is the latest version, and so I'll do that, but I could install an older one if I wanted, Python 3.13. So if I run that, you can, maybe it's very small and hard to see, but it created a hidden folder in here inside the current working directory. So if I go ls-l, wrong one, ls-a, then I can see it's called .venv. This is where Python has just been installed into. So this thing is called the virtual environment, and venv. If I want to, I can follow the prompt here from UV, which is to run this command source.vim activate. And now my prompt has been modified to let me know that I'm in this I've activated this virtual environment. So now if I run Python, well, if I ask for Python, then it will give me the one that's been put inside of this folder that was just installed. So if I run python test.py, well, it will still crash because we haven't installed PyTorch yet, but it will crash because this version of Python doesn't have PyTorch yet, so we can fix that. UV command to install new packages is uv pip install, and then the name of the package, so torch as an example. We can see that installing PyTorch wasn't as simple as just downloading one package. It really had these 10 because PyTorch itself relied on the other 9 to operate. So now if I run python test.py, it'll actually run because it will remember the first line of that was import torch. Import torch here. And now because we installed torch inside of this copy of Python, and we can dig down and find it if I could really remember where these things live, side packages. Yeah, so it's installed it here somewhere, but typically you don't go hunting around inside the Vim folder unless something's drastically gone wrong. But that's where it's been installed to. So again, if we're finished with this Vim, we can deactivate it so that we're no longer sort of defaulting to using this version of Python. And let's see if I'll close the VS Code and reopen it again inside this folder. So, okay. So this part here of the terminal inside VS Code was just a copy of what we ran earlier. And so this part at the bottom is actually the new section. So now that VS Code has opened up this folder again, it's noticed that there's a venv in there because we're using one of those standard names, either .venv or just venv directly without the dot. Because it's one of these standard ones, VS Code knows to look for it and then activated it for us. So now if we press play here, it will make a new terminal, activate that virtual environment, and then run the code. And it actually works this time. And let's test if we make a new Jupyter notebook. So I'll do Command-Shift-P to bring up the palette, type new Jupyter, and I'll save that in this same folder. I'll just double check that this also works. Import torch. Okay, so when I write my bit of code, I went to run it with Shift-Enter. It's still asking me to find which Python to use. So if I click Python environments, VS Code's got a list of all the different Python environments I've installed all over the place. But it's recommending the virtual environment that it's found in the local directory because that's the closest one. So if we click on that, then it will helpfully tell us that we actually need a little bit more in the environment itself to be able to run Jupyter Notebooks. So we just hit yes, install, and it will go off and install in the virtual environment these extra couple of things that we need for Jupyter to run. And then we've got it. We've got this setup here between using the specific version of Python that we asked for, installing packages that we need. So what else do we need? I mean, for uv pip install packages, you can specify specific versions if you need them, like this. I don't know if Pandas 2.1 is even a real package, but Pandas is a real package. I don't know if version 2.1 exists. So we'll see what that does. Otherwise, what other things are there to show? Okay, so one thing to point out is that these virtual environment folders are kind of ephemeral in a sense. Yeah, so that didn't work for some reason. But if that was a legitimate version of Pandas, then that would have installed perfectly fine. So back to what I was saying. So the Venv, it's kind of stuck where it is. Once you've created it, you can't change the location of the Venv. You can't move it up a directory or down a directory. It just breaks it straight away. And by the same token, you can't reuse a Venv across two different computers. So I do all my coding in Dropbox, for example. I cannot create a Venv on my Mac computer and then expect it to work when I load up the same Python on my Windows computer, or even a different Mac for that matter. So luckily, recent versions of Dropbox allow you to have this file called rules.dropboxignore file, and you can put patterns in here which says ignore certain, like don't sync certain folders to the cloud when inside your Dropbox folder. So you can add a pattern that matches virtual environments, common names of virtual environments, and then each computer you'll just have to do a UV venv UV install the packages you need one by one. So if you have a lot of packages for one project, what I do, there are other ways to do this, but I create a file called requirements.in, and I just list all the packages that I need for this project. And if I want to, later on, if I want to recreate the environment on a new computer, then I can just do uv pip install and then -r to read from the requirements file. And it just goes line by line through that file and installs all of them. And you can be more specific here. Like if you did need NumPy 2.0 or something, you can put it here. But if you don't need it, I just leave it blank. And later on, if I'm sort of finished with the project, I want to sort of wrap it up or save the state of it, you do uv pip freeze, and it'll spit out all the details of what exactly you were running, all the versions. You can save that to requirements.txt file, and then that will be if this is like if I'm putting a project in cold storage basically, and I want to be able to rerun the code in 1 to 5 years time. I'll know that this is all the specific items I had at the time. I need to reinstall these old packages to be able to make sure the code runs exactly how I had it running in the past. Okay, so that's all for this. UV has a lot more functionality to it. I'm sort of only giving you a very small flavor of it. I'm only showing you how you can use it to download and install Python and to install packages, but it does way more than that. It's very popular, sort of becoming the de facto standard for how to operate Python within the last 2 or 3 years. I would say it's really taken over. And this is different too. I used to use Anaconda quite a lot, which had all these same kind of concepts of virtual environments, but they didn't operate in exactly the same way. They didn't really create these .venv files inside each project. I would put them all in like a centralized location, and you would have to memorize the names. Okay, for the AI environment was for such and such project or 2 projects, and this other one was for some other project, and so on. So I used Conda for a long time. It's still perfectly acceptable, but if you're just starting Python now, it seems like, from my little view of the world, it seems like everyone's using UV, so you might as well jump in there. It does have a bit more terminal requirements to it compared to Conda. There are ways you can run Conda with like a graphical environment, so maybe Conda's a little bit easier from that perspective, but starting out, I'd recommend you use UV and just get used to a bit of terminal commands. Okay, so I think that's all. Thanks very much.